Okay, so in this video we're going to be looking at differentiating powers with negative and fractional indices. But before we do that, I just want to go through 3 recap questions. Differentiate y with respect to x. So what we're going to do is we're going to write y dash is equal to 35 x to the power 4. Okay, we bring down the power, times it by the 7, and then we reduce the power by 1. 5 minus 1 is 4. Okay, pause the video, have a go at question B and C by yourselves. We're differentiating each of these with respect to x. Okay, question B, y dash is equal to 32x to the power 7 minus 6x squared. And question C, I'm going to use dy dx. They mean the same thing as y dash. We've got 24 a x cubed minus 11c. Okay, there's no x here, so this is just a constant, so that disappears. But there is an x here, so we've got minus 11 times 1 is minus 11, or minus 11c times 1 is minus 11c. Okay, so let's have a look at how to differentiate powers with negative and fractional indices. We'll start with negative indices. So what we're going to do here is we are going to differentiate each function. We've got y is equal to x to the power negative 20. So y dash is equal to, we're going to bring down the power, and we're going to reduce the power by 1. But what's minus 20 minus 1? Is actually minus 21. Okay, it is not minus 19. Okay, you're adding 1 in that case. If we want to write this without any negative indices, we can just bring the negative, the term with a negative power to the bottom, to the denominator. So we've got negative 20 over x to the power positive 21. Okay, question B. Y dash is equal to, bring down the power, 6 times minus 1 is minus 6. X, reduce the power by 1, that's minus 2. So that's the same as saying minus 6 over x squared. Okay, pause the video, have a go with C by yourselves. Okay, question C. Y dash is equal to, bring down the power, minus 5 times minus 4 is positive 20. Reduce the power by 1. So our final S is 20 over x to the power 5. Right, differentiate each function, giving your answer without negative indices. So what we need to do here, we can see in this question, f of x is equal to 1 over x. What we need to do when we differentiate, we need the indices, because then it makes it easier for us to bring down the power and then reduce the power by 1. So what we're going to do here is I'm going to rewrite the question as x to the power of negative 1 first, and then we can differentiate it. Now we can say f dash of x is equal to, bring down the power, reduce the power by 1, which is negative 1 over x squared. Okay, pause the video, have a go at B and C by yourselves. Okay, question B. We're going to rewrite this question as 5x to the power of negative 2. Okay, we're just going to bring this up to the front, to the top with a negative power. We can now differentiate this. F dash of x gives us negative 10 x to the power of minus 3, which is negative 10 over x cubed. In question C, I'm going to rewrite this. F of x is equal to 1/3 x to the power of minus 5. Okay, we're just bringing this to the top. Now we can differentiate it. F dash of x is equal to, bring down the power, you get negative 5/3 x to the power of negative 6, which is negative 5 over 3x to the power of positive 6. Okay, next question. We want to differentiate f of x is equal to 16 over x cubed minus 24 over x squared. So again, I'm going to rewrite this as 16x to the power of negative 3 minus 24x to the power of minus 2. And now we can differentiate this. F dash of x is equal to negative 48 x to the power of negative 4 plus 48 x to the power of negative 3. So if we want to rewrite this, we can. Negative 48 over x to the power of positive 4 plus 48 over x to the power of positive 3. Question B, we want to use a common denominator to write our answer as a single fraction. So here was our answer. We want to write this with a common denominator. The lowest common denominator will be x to the power 4. All I need to do is times this one by x to make it x to the power 4. So I need to times that one by x as well. So f dash of x is equal to negative 48 plus 48x all over x to the power of 4. That's it. Hence, find the point on the curve y equals f of x where the tangent is horizontal. So the tangent is horizontal when f dash of x, when the gradient is equal to 0. Right? This is the gradient function. So when the gradient is 0, that means the tangent is horizontal. So what we're going to do for part C is we are going to make this negative 48 plus 48x all over x to the power 4. We are going to make that equal to 0. Now, in order for a fraction to equal to 0, the numerator has to equal to 0. Right? Because 0, whatever is at the top, 0 divided by anything will equal to 0. Other than 0, as in the denominator can't be 0. Because we can't divide by 0, we get an error. So what we're going to do is we're going to times by x to the power 4. That leaves us with negative 48 plus 48x is equal to 0. We'll move the negative 48 across. So x is equal to 1. We're halfway there because we want to find a point. It's not just x equals 1, we need the y value as well. So what is y when x is equal to 1? Well, here is our y, right? F of x. F of x is the same as saying y. So I'm just going to say f of 1. So the y value when x is 1 is 16 over 1 cubed minus 24 over 1 squared. Okay, that's according to this. Which is just 16 minus 24, which is negative 8. So at 1 minus 8, the tangent is horizontal. Okay, so let's just double check that with the graph. Here's the graph of f of x is equal to 16 over x cubed minus 24 over x squared. You can see here at this point, at 1 minus 8, that the gradient of the tangent will be 0 because the gradient of tangent, or the tangent is completely horizontal. Okay, let's move on. In each function, first divide through by the denominator, then differentiate. So we can see here that in question A and B, we've got one large fraction, but that makes it difficult for us to differentiate. So what we're going to do is we're going to split it up. We're going to rewrite this as x cubed over x. plus x squared over x, that one over that, plus x over x, which is just x squared plus x plus 1. So if y is equal to this, we can now differentiate that. Y dash is therefore equal to 2x plus 1. I'll get you to pause the video, have a go with question B. Okay, question B, we are going to rewrite this again as 5 over x squared minus x squared over x squared plus 5x to the power 4 over x squared. Let's rewrite this as 5x to the power minus 2 minus 1 plus 5x squared. Now I'm happy for you to go straight to this without having to having to write it like that. Okay, that will save you time. Now that we've done that, we can differentiate it. So y dash is equal to negative 10x to the power minus 3 plus 10x, or negative 10 over x cubed plus 10x. Okay, make sure your notation is correct. We do not put the y dash here because we're not differentiating it yet. We're just rewriting what y is equal to. When we differentiate, then we put our dash. Alright, so that's how to differentiate negative indices. Let's have a look at how to differentiate fractional indices. So again, it's going to be the same thing. We're just going to bring down the power and then reduce the power by 1. So in question A, f dash of x, bring down the power, and reduce the power by 1. What is 4/3 minus 1? Is equal to 1/3. Okay, question B, f dash of x, bring down the power, reduce the power by 1. What's 1/4 minus 1? It's minus 3/4. So if you want to, we can rewrite this as 1 over 4x to the power positive 3 over 4. Alright, pause the video, have a go with question C and D. Okay, question C, f dash of x, bring down the power, reduce the power by 1. So we've got negative 1 over 5x to the power positive 6 over 5. And question D, f dash of x is equal to bring down the power. I'm gonna rewrite this. F of x is equal to x to the power of negative 5 over 2. Okay, I'm just going to convert it to an improper fraction. And then I'm going to differentiate it. So we've got negative 5 over 2x, reduce the power by 1. That's negative 7 over 2. So we have negative 5 over 2x to the power of 7 over 2. Okay. Write each function using a fractional index, then differentiate it, then convert it back to third form. So question A, we have y equals 12 root x. So we're going to rewrite this as 12x to the power of half. Okay, because the square root of something is the same as saying to the power of half. Now we're going to differentiate this. So y dash is equal to, bring down the power, 12 times half is 6. X, reduce the power by 1. Half minus 1 is negative half. So that's the same as saying 6 over x to the power positive half, or 6 over the square root of x. because we want to put the answer back to third form. Alright, question B. We're going to rewrite this as y is equal to 4 root x, or 4x to the power of half. Okay, because the square root of 16 is 4. So y dash is equal to 4 times half is 2, x to the power of half minus 1 is negative half. So that's 2 over x to the power of half, or 2 over root x. Okay, pause the video, have a go with question C. Okay, question C. Y is equal to 3x to the power of negative half. Okay, because we need to bring the x to the top. So it's going to be a negative power, and because it's a square root, it's half. Now we can differentiate this. Y dash is equal to 3 times negative half is negative 3 over 2. X to the power of negative. Well, what's minus half minus 1? It's minus 3 over 2. So that's the same as saying minus 3 over 2x to the power of positive 3 over 2. And if we want to convert this back to third form, that is the square root of x cubed. Square root of x cubed. Okay, the denominator of the fractional index tells us what kind of root it is. Because it's a 2, it's just a normal square root. If it was a 3, it's a cube root. If it was a 4, it's a fourth root, etc. Okay, write each function in terms of a power of x, then differentiate this. Now, I know this was assessed in a Year 12 assessment task, and students did pretty badly with this. What we need to do is we need to simplify the function first. We need to simplify this. So technically here we've got f of x is equal to x cubed times x to the power of half. Right, we can rewrite this third. What do we do with powers when we have the same base? We add the powers. 3 plus half is 3.5, or 7 over 2. And now we can differentiate it. F dash of x, bring down the power, reduce the power by 1. And that's it. We don't actually need to do anything else. Okay, question B. Let's rewrite this. F of x is equal to x to the power of minus 3 times x to the power of minus half. Okay, I'm just bringing this to the top. So they now have negative indices. And what do we do when we have terms with the same base? We add the powers. So we're going to simplify this. What is minus 3 plus minus half? So we have minus 3 plus minus half. We get minus 3.5, or minus 7 over 2. So f dash of x is equal to negative 7 over 2. X to the power of minus 9 over 2. Okay, we need to reduce the power by 1. And that will give us an answer of negative 7 over 2x to the power positive 9 over 2. Okay, last bit. Divide through by the denominator, then differentiate. So we're combining a few different skills that we've learned so far in this lesson. We're going to split this up into two separate fractions, and then we'll differentiate. So we're going to rewrite the question as y is equal to 10x over root x, or x to the power of half, minus 6 over x to the power of half. I'm going to simplify this. What do we do when we divide terms with the same base? We subtract the powers. So y is equal to 10. What is 1 minus half? It's half, so x to the power of half, minus 6x to the power of negative half. I'm just bringing this to the top. Okay, now that we've done that, we can differentiate this. I'm going to use dy dx notation this time. Okay, it doesn't matter which one you use. I'm just doing this so that you get used to seeing it. 10 times half, 5x to the power of negative half. Negative 6 times negative half is positive 3. X to the power of minus half minus 1 is minus 3 over 2. I'm just going to write this without any negative indices. So this is equal to 5 over x to the power of positive half plus 3 over x to the power of 3 over 2. Alright, why don't you pause the video, have a go with question B by yourself. Alright, so for question B, I'm going to rewrite this. We have y is equal to 3x over x plus 4x to the power of half over x. That's just equal to 3 plus 4x to the power of, well, what is half minus 1? That's minus half. So now we can differentiate this. This disappears. Minus half times 4 is minus 2. X to the power of minus half minus 1 is minus 3 over 2. Or we can rewrite this as minus 2 over x to the power of positive 3 over 2. Okay, and that's it for this video.